Welcome to Los Angeles Data Platform User Group. This session will be recorded and shared on YouTube and Rumble, I run it by the speakers. Good time of day, everyone, wherever you are. By the way, please feel free to drop your city and name into the chat so we know which communities we're serving. Again, welcome to Los Angeles Data Platform User Group. Thank you for joining us today. My name is Steve, and I'll be moderator of this virtual meeting. I'll be joined, hopefully, by Yelena. If you're new to our user group, this is the way to find our meetings, either Eventbrite or Meetup. You can also send us an email. All the hyperlinks on this slide are clickable. If you're attending us for the first time again, or you try to follow us on social media, here's all the links. You can follow us on different digital parts of the world. You can also join our mailing list. We have weekly newsletters with stuff to read, also reminding you on upcoming meetings, updating you on the recorded video that we have on YouTube or Rumble. You can either scan the QR code or, again, click on a hyperlink. And this event is sponsored by Microsoft, TN3, and Data-Driven Technologies. Most people know Microsoft. TN3 is a company that provides virtualized storage, and Data-Driven Technologies is the nonprofit that finances this user group as well as SQL Server in Los Angeles.
Yeah, great, thanks. So my name is James Serra. I'm a data and AI solution architect at Microsoft. I work in the federal civilian industry, so I deal with a lot of government agencies. I've been at Microsoft quite a long time. There's my blog where I have a lot of other follow-up information you may want to do for self-learning, and then there's my email if you have any questions after the presentation. I will say during the presentation, just put questions in the chat. I will keep an eye out on it, and I will take pauses during the way to check out any of the questions that you have. I've been doing this quite a long time. I'm actually coming up on about 40 years now, and I've had a lot of different roles in my long career and have been at Microsoft the last 9 years, mostly in pre-sales roles. I was briefly gone to EY to help build a data fabric, and when I came back to Microsoft, I also was working in Microsoft Consulting Services on the development side. And then about a year ago, I switched back to the pre-sales part where I spend my time educating customers. And a lot of the recent discussions have been around data architectures. Everything that I'm talking about today is coming from, or actually I created the presentation initially and then had a lot of interest in the architecture topics, and then found out a lot of people didn't quite get a lot of the common data architecture concepts. So I wrote this book, which is almost done. It actually is done except for the laying out of the book. So you can get it for pre-order on Amazon. You can only pre-order the print version. So if you want the ebook version, wait for that to be pre-ordered, and that should be able to order and available in early February. So if you want a deeper insight into a lot of the things I'm talking about today, my book can do that. This presentation I've been giving for a while now, but just for this group, I recently being this week, updated it to include some new refresher material, repackaged a few things in there. So hopefully you'll find some value out of it. For those of you who have tried to understand all this on your own, because I'm going to go into just a little bit about the concepts, but then into the architectures, it can be very daunting. And a lot of people, I think, feel like this. If you try to figure it out on your own, you may end up like Towley, for those who watch South Park, where you have no idea what's going on. And a lot of customers I talk to feel this way going into it. And usually by the end of the presentation, they at least have some light into understanding this also. Hopefully that'll happen today. The agenda is, I'll briefly talk about relational data warehouse and data lake. and then get into the 4 architectures and then touch a little bit on data mesh. Sure. I always have to say these are my opinions, not those of Microsoft. So if you hear something and you don't agree with it or angry about it, and you're going to go complain to somebody, complain that it's James Serra's opinion, not Microsoft's opinion. So, so there's in a lot of this, there's no official opinion from Microsoft on these things. So everybody at Microsoft is free on their own to kind of have their own opinions, but need to make clear that we're not representing Microsoft in this presentation. All right. Oh, Douglas has already got a question. ETA for government version of Fabric. Not soon. Don't expect it for a while. I can't give you any more information, but for those who are not aware, Microsoft's got the public commercial cloud that we all know and love, and then they have a government cloud, and there's reasons why it's a separate cloud. They even have secret and top secret cloud. And so things that have come out in commercial and Azure take a while to go on Azure Gov because they got to move all the code over and change some of it. They got to get special stamps of approval from all these agencies. So there's always a delay in that. And unfortunately, being a federal civilian, the first thing I ask is, are you in a commercial cloud or Gov cloud? Because they say Gov, I have to go, oh, well, some of the things I can't really talk to you about now, like Fabric, because it's going to be a while. Yeah, the state of Washington will be sad. Yeah, thanks. So relational data warehouse, what is it? I'm assuming everybody here kind of knows what relational data warehouses is, but I always like to level set. It's not for OLTP applications in there. This is collecting data. People will say it's write once, read many. The idea is you can pull all this data from various data sources, usually relational databases. You're going to use ETL, and you're going to land in a data warehouse in there. And then you're going to do reporting off that. So that the warehouse is a central repository for all these different subjects, and it contains the single version of the truth. Now, in these architectures I'll talk about, even though you may understand why you have relational data warehouses, you could say, well, why do we have additional copies of the data? And because even if we're not using a relational data warehouse, like in a data lakehouse, but you still need copies of the data for various reasons, some of them which I list here. The idea is, especially if a lot of reporting is done on a source system, no matter what, you want to avoid people writing large queries against that source system because, say, it's the CRM system and people are trying to do a lot of updates and inserts, and all of a sudden everything's running real slow because somebody had some malformed SQL statement that's running against it and hogging all the resources. And I was a DBA for many years, and I got familiar with SQL Server and the kill command because somebody would just go run something. So the idea is pull all that data off of the source systems, put it in a relational data warehouse, and run those long-running queries on the data warehouse, so you're not stressing out the production system. Also, a couple of things I'll just point out. You can rename fields and tables. If you're familiar with a lot of operational systems, they have sometimes funky names for tables, T116. And so you can rename them because in the end, you're trying to get self-service BI. So you want to make it easy for people to go into the warehouse and create their own reports. Well, a usual way to help to do that is to rename the field so it's easy for them to understand. And then I'll pick on another one here, application upgrades. If I have these reports and they're going against the source system, and the source system gets upgraded, and all of a sudden these tables, fields change names, the reports are all going to blow up. Well, you shield that from you by copying the data to a data warehouse, running the reports of that data warehouse. And if the upgrade happens, it'll break your ETL, but it won't break all those reports. So those will keep going. And then, yeah, they won't get data for a while, but they can still get the older data until the ETL is fixed. So another reason to have a data warehouse and that. Okay, so data warehouse relation, and I'm referring to relational databases here in this. Data warehouses can certainly be in other types of storage, which we'll talk a little bit about in there. But the majority of people, historically especially, have been warehouses that are in relational databases, like a SQL Server. Then about 10, 11 years ago came the data lake. The data lake is a Schema on read, meaning you don't have to do any upfront work to land data in data lake. In a relational data warehouse, you got to create the database and the table and the schema and the fields and write all the ETL to copy it in there and some specialized software. A data lake schema on read means I just can dump files in there. And so before it was called schema on write. Schema on read means I can pull the data out. When I pull the data out, I then get the schema. But before then, I could just start dumping all these files in the data lake. And as pictured here, it could be all sorts of data in there, even streaming data. It could be any kind of format in there. It's really just a glorified file folder. And just like you're doing in your laptop, copying data in there. You do the same thing in a data lake. Now it's got a lot more features in it and it's in the cloud, but all a data lake is an easy way to land data. There's no compute associated with it. Like a relational data warehouse is going to have both the compute and the storage tied to each other. In a data lake, it's just storage. There's no compute. You will use compute to modify the data, which we'll talk about in a little bit, but data lake on its own is just storage. Why use a data lake? Many reasons. I'll touch on a couple on here. If you have a relational data warehouse and you don't have a data lake, you likely have a maintenance window. So you kick people off at night, you load all this data into the data warehouse and staging tables. You then clean all that data, use all that compute, usually expensive, and fingers crossed that by the end of that maintenance window, everything runs. People can jump back on in the morning. If there's problems, they can't get on. And I've been through that in many instances in there. So that maintenance window becomes really important. With a data lake, think of it as in the relational warehouse, you have those staging tables, you clean the data, you copy the data in production. Let's pull out those staging tables and put them in the data lake. So what you do is you pull all the source data, it lands in the data lake. It's just storage. You pick any type of compute you want to then clean the data. And most, if not all products nowadays can work against a data lake. So you can use, say, Databricks and take that data in the data lake and do all the cleaning there. So you don't need a maintenance window anymore for the relational data warehouse. Well, now maybe you may have a 5-minute window where you're loading the data, but all that heavy compute is done in the data lake. So you offload that. Now you can have a 24/7 data warehouse. You can do things with that compute to make it much faster than transformations were done in the data in a relational data warehouse, because you can fire up dozens or hundreds of Databricks clusters with high performance on there and do all that cleaning on there. So that's the big reason why data lake has become popular, to offload all that performance. And then another last one I'll point out is data exploration. I can take data and go, I don't know if this is really valuable. Let me copy it into the data lake quickly. Let me have a power user who can use technology to explore data in the data lake, which has gotten very easy now, but traditionally it was harder. They can go in there and they could see if this has got value, and then maybe you want to then copy it to a relational data warehouse, but you've not gone through the pain, and I've done it many times, where an end user comes to you and says, we have this data, it's going to be really helpful. You go, okay, you go and create a database and the schema and fields, and you write all the ETL, you do all this work, and you go to the end user and say, okay, all the data is sitting in the data warehouse, because you also got to create a nice model for them, maybe even a star schema, and then they go, oh, actually that data is not helpful, and you go, I wasted all this time on that. That problem goes away. Dump the data in there, use one of those tools to explore it, and then get a better idea. Or maybe you just have a one-time report, a query on that. So that's the other great thing that a data lake allows. So there's a lot of other reasons. In my book, I have about 20 reasons, but those are just a few of them. All right. So again, put your questions in there if you have any. I don't see any yet. And we'll jump to our first architecture, the first of four, the modern data warehouse. This has been traditionally the way things have gone, maybe 7-8 years ago, where there was a combination of the data lake and the data warehouse. The idea being, let's use the power of both of these. Let's use these in combination in an architecture and use what each one is good at. And listed here, again, this is changing, but listed here is traditionally data lake has been really good at that staging and prep area, which I just talked about. So I'm recapping some of the things here. And then the data warehouse would be used for the serving and security layer. The reason being, data warehouse has been around a lot longer. It's got some really great things built into it, like security, which the data lake has very little of, other than putting security against at a file level or a folder level. But things like rule of security, column of security, they don't exist in the data lake. So a lot of customers would do all that staging and prep in a data lake, and they'd make that off limits to all but, say, data scientists and power users. Everyone else would use a data warehouse for the data. So you copy the data lake into the data warehouse. People are used to a data warehouse, the relational format. It has other benefits like high number of users on there. A lot more tools have been made for the relational data warehouse in there. And so the way to look at it also is a data warehouse is where you already know the question. So you're going to go and create those relational databases and the reports and the dashboards to answer those questions. The data lake is very good when you don't know the questions. You want to explore the data, then maybe you figure out this data could be useful. Here's the questions I'll ask. Now I'm going to move it to the data warehouse. So what this looks like is in 5 stages. And most solutions, all the architects I'm talking about, are going to have the 5 stages. Some people call them something different, but the whole idea is you're going to ingest data from various sources with a traditional data warehouse or a modern data warehouse. I call it both. It could be relational databases. It could be structured or unstructured data. Usually not unstructured data, but most warehouses now support that. Mostly going to be batch. We'll talk about real-time streaming in a minute. You're going to ingest it into a data lake. Now, this gets into data lake design, where you have different layers, usually at least 3 layers, a raw clean presentation. The idea is the data lands from that source system as is into the raw layer, and it could be a CSV file, Parquet file. You'll then, in some cases, conform all that in a separate layer into what's traditionally a Parquet format, because that's popular and it's very fast. You could have that as a separate layer, or you could just make it part of the clean layer. But either way, you're going to conform it into one particular format. Then you're going to clean it in an enriched layer. You're going to do that with data lake compute, as I show here, which could be any number of products. And then the data is clean, but you still may need to do more of it to make it presentable. That means maybe I join the data with multiple tables together. Maybe I master the data. Maybe I aggregate the data. Maybe I create a star schema and I put that in a presentation layer. However, traditionally, tools have been difficult for end users to use data sitting in the data lake. Again, that's changing, but they would copy it to the relational data warehouse on here. And that would be the serving layer. And I say model because the data as it copied in there may be in third normal form. And then you could model it into a star schema, and you could have multiple star schemas. And that's the schema on right on that. So you model the data to make it easier for end users to create the reports, and that's where step 5 comes in. So you can look at this and go, well, that's a lot of work to get the data, and it's extra expenses and storage costs. Yeah, but the benefit is the data gets to a format that is so easy to use, especially if it's in a star schema, that an end user is going to go, I got this. I'm going to create this reports. I don't need to bother IT. So IT does this work to put it in the format that all the end users can do reports and dashboards and do analytics on it without bugging the IT people. Now you may have listed here a data scientist who says, just give me the data in the data lake. I don't need relational storage. I love it in a file format. I may even not want it enriched. Maybe I want it in raw for various reasons for building machine learning models, so they can have at it. And so this could help all sorts of people with this type of architecture on here. And this has worked great for many years. It still is used a lot. And the use case is minimized for this because of the other architectures coming up, but still wide, popular and will continue to be. Now, the next architecture that came around, called the data fabric, is, and this is my view, because there's a lot of people that, not a lot, but some people have different views of what a data fabric is. And some people even call it modern data warehouse a data fabric now. I separate out the two by saying a data fabric is just like an evolution of what you had in the modern data warehouse. And it allows you to have more features to ingest more types of data. It's a fabric. It's weaving out in your environment, in your company, and allowing you to pull all sorts of data and centralize it into a data lake, and then eventually a relational data warehouse in there. So it's giving you more tools into that diagram I showed you before. So data access policies, more types of security on it, a metadata catalog for those with knowing Azure, something like Purview. That's where the data fabric would master the data. Maybe you have some virtualization on there, and then this is where you get into real-time processing. You may have APIs for everyone to access the data. And then you could split out a data fabric into building blocks where you can say, I'm going to create this cool ingestion piece. And there may be other people in my company that don't need a data fabric, but they could use this ingestion piece for something else they're doing on. And that's what I did when I was at EY. And then data fabric could just be a product that you can sell. And I see a number of consulting companies doing that. So it gives you all this extra technology, and the diagram will look like this. So it's an add-on to before. So you see, well, now I'm ingesting real-time data from these IoT devices or social media on that. I got extra security on that, and I got a metadata catalog on there. So very close to the other one, just has additional functionality on top of that. So that's my version of a data fabric. Gartner has what I call an intelligent data fabric, because they talk about automating the process of collecting all this data, which I don't know any tools that do that yet, so I'm not high on that. Maybe we'll get there one day. But for now, this is where I find most customers building solutions. They look like this. All right, no questions yet. So we'll jump on to the data lakehouse, the third architecture. Quick history discussion. For those as old as me, you remember the 80s. That's when I got started. I actually got started in 1985. Wow, I'm so old. And that's where I was a COBOL programmer and got my first experience with a data warehouse. I don't even think it was Teradata. That was one of the first ones in there, but we had something else on a mainframe that we called the data warehouse. And those solutions, the Teradata and mentioning the Teza, were all in one encompassing, meaning they had the relational storage, they had the compute, they had the ETL, they had the reporting. It was all in a box for that. And of course, they would handle big data. Back then it was like a gigabyte, which I have way more on my phone now. But you needed these separate systems, again, for the reasons I said before, to reduce the stress of the OLTP systems, was usually the case. These data warehouses were using MPP technology as opposed to SMP. Won't get into that. You can read that in the book. So they lasted for a long time, and they're still around. I still have customers that are using Teradata and Teza on-prem. They're all trying to migrate to the cloud, but they even have those versions in the cloud. All right, so along came in the late 2000s data lake, and data lakes were this wonderful land of unicorns and leprechauns and rainbows that you could put all your data in a data lake, and it would magically come out all nice and clean and easy to access, and you can do reports off of it, and you didn't really need relational databases anymore. And I actually had companies, and I have some very funny stories I can get into if we have time, but they just failed miserably in their idea that data lake can be all encompassing. And they quickly find out, because the technology was just too difficult. Imagine trying to tell an end user I put your data in the data lake and it's sitting there in files, and go and use Hive and pull the data out there and create your reports. And that just didn't go over well. So what happened was they said, hey, the data lake, we shouldn't use it for everything, but there are some great use cases for it. And that became the modern data warehouse. As I said, for the transformation piece of it, that's where the data lake came into play. And so people combined it with the relational data warehouse. Okay, the best of both worlds in there. That worked fine, still works fine. Then came a new approach to data lakehouse. The idea was, hey, let's just use a data lakehouse and let's not use relational databases anymore. Well, wait a minute, James, you just said that didn't work. What's the difference now? The difference is the technology came about called Delta Lake. Delta Lake is a transactional software storage layer that runs on top of an existing data lake, giving it relational data warehouse-like features. It's not its own storage. And what it does is takes the data lake, and the biggest benefit, I should say, is that it supports insert, delete, update, and merge commands. A data lake doesn't support that. You have to go through this rigmarole. If you want to do like an individual update of a table, like a CSV file, you have to pull the whole table in, update that one row by reading everything, and then write it back out as a full table in there. It takes forever, especially for large files. Delta Lake, I won't get into details of how it works underneath the covers, which is just Parquet and has a log file, but it makes it much, much faster to do those individual commands on there. It also gives you things like ACID transactions for an individual table, time travel. I can version data as it goes in there for rollbacks or audits. It has one unified platform for streaming and batching, and it's things like schema enforcement, so it won't kick people out. It won't blow up your ETL. It will kick data out that's not in this particular proper schema. Other things here, performance improvements. So Delta Lake is really adds a lot of great functionalities to data lake. So when it first came out, I was like, I can see some use cases for this where you can not use a relational data warehouse. The technology has gotten better and better to the point where most customers now are using Delta Lake and they're not using relational storage anymore. And it's very easy to use. As indicated on the right-hand side here, to save something, if you're using, say, Spark, you would previously say, I want to store it in Parquet. Now you just say Delta, and that's it. So you can convert everything quite easily to Delta. So this gives you some great use cases for solving the 5 problems that you find in most modern data warehouses in there, is keeping the data lake and the data warehouse consistent. If you have a bug in there, now you can have different answers to the same question. The data warehouse is always going to be older, so you have that. Maybe you run it once an hour, maybe once a day, but you have that problem of them being different, older. And that can be problems with people going against the warehouse for reports, others going against the data lake, and they get different answers. It's cheaper, even though storage is very cheap nowadays. But the idea is you have 1 copy instead of 2, so you save a little bit of money that way. If you have 2 copies, or you have more risk of security risk on there, so you're helping with that. And then the complexity of having to hire people who know how to handle both of those technologies. Now you're reducing the technologies to just the Delta Lake and the data lake, and that generally a lot easier than trying to have the proper skill set for both a data lake and a relational data warehouse. So what does this architecture looks? It's just very much like the data fabric, with the exception that we have this relational serving layer instead of relational data warehouse. Now I say you have a relational serving layer because you still need to present it in a way that's easy for end users. You can't go and say everything's in a Delta Lake, here's the files and folders, have at it. You want to take that data and have some schema on read on top of that, which is not extra storage. It could just be something as simple as a SQL view that's pointing to data in a data lake, but gives the schema inside that view. It could be a data set in Power BI That's the reserving layer, and they're now called a semantic layer on there. So a lot of different things you can do to present it to an end user. You don't have to do it that way. And some of the tools like Power BI can go right against the data lake, and you can avoid creating. You're still going to somewhat create a serving layer with a data set in there, but you could minimize modeling. But my point is, you want to have a good modelers, and you want to put that over the data that's sitting in a Delta Lake on that. So that's the big change. But everything has got trade-offs, and that's where I have opening a can of worms. And this is where I try to be upfront in my book. Everything that I talk about there is going to have those trade-offs. You need to be aware of those trade-offs. And here are many trade-offs. Skipping a relational data warehouse. Queries are going to be slower. That's never going to change, even though the queries can be very fast now in a Delta Lake. But they don't have things like advanced statistics and indexing. If you think of materialized views, these query pans optimizations in there, it just doesn't exist in a Delta Lake. And then get into massive parallel processing for those who know what it is. And so you have to look at what do you need though. If I can run queries in 2 seconds in a Delta Lake, that may be fine. It could be 10 or 20 seconds that you're happy with. But if you need subpar millisecond response time, you're just not going to get that with a relation with a Delta Lake. So you may want to copy that data and just that data into a relational data warehouse to get that speed. Now, there's a lot of workarounds to that, and that's why at the bottom I say a lot of technology addresses these concerns. I mean, one right off the bat is I can copy that data that's not fast enough into, I can import it into Power BI and just use that, and so that's one way around it. But you need to be aware of Delta Lake on its own is going to be slower. It doesn't have roll-up security, column security, things I talked about, other things listed here. If you want some of that stuff, you're going to have to copy that data into a relational storage in there. The relational database is great in that it's a forced metadata layer. I cannot get to the data unless I go through the metadata. So you do that work up front, but it makes it easy to find data. In a Delta Lake, the metadata is optional. It could be inside the file as a first row and like a CSV file. It could be separate and some file that you're using that is like a manifest file that has all the metadata in there, or it could not exist at all. And so that could be a big problem. Some of the technology is trying to overcome this, but you have to be aware there's no forced metadata layer. And so that may trouble some people who can't understand the data because they don't know where the metadata is. Concurrency could be one. It could be slower to have a lot of people accessing data in the data lake compared to relational dataways. And then there's just missing features that you don't see in a Delta Lake, like SQL views, referential integrity doesn't exist. So, and then finally, the products must support Delta Lake in order to use it, which most things do anyway nowadays in there. So my point is just go through this and then see if you're okay with this. And if you are, go build a data lakehouse. I kind of tell customers now, build the data lakehouse until you can't. If you run across an issue, it doesn't mean it's all or nothing. It doesn't mean I have to copy all the data in a relational database. Copy just that data that's not giving you what you need. Maybe it's performance into that relational storage in there, or maybe you need some type of encryption like TDE, and you copy it in there for that piece of data. So that's where I see a lot of customers doing in there. They may say we're going to go to data lakehouse and we're going to get rid of a relational data warehouse that we've had, but there's a couple of cases that we got to keep it in there, at least for now, at least and at least until the technology comes along that improves this on there. And if you look at things like Fabric especially, it's made it really easy. Fabric is a data lakehouse, and there is no relational storage in Fabric. So the idea is everything you do, and this is not I don't get too much into Azure technology in here, but the Fabric technology is everything you do within Fabric lands in a data lake in Delta format on that. And so all the tools were made to understand Delta Lake, and they've added a lot of additional functionality within the Delta Lake to get the performance you need. Even things like roll of security is inside of Fabric, and not yet to the level that you can put the roll of security on top of the data. That is coming in there. But when that comes there, then the roll of security is on top of the data, and no matter what product you use, it's going to go through that roll of security. And then you look at other things in there, like concurrency is greatly reduced, is greatly improved in the Delta format in there, because you can have multiple computes all going against the same file in there. And then the platform is so easy to use that you don't even, end users don't even realize that they're using Delta Lake. They just see this cool interface that's really easy to upload data, and they're not realizing it behind the scenes is putting in Delta Lake. So in the end, a lot of these concerns have gone away, but not everything, like reference integrity and that. So where do I do that? Well, you have to do that in code. So just be aware of all these things. Check out the products that exist to see how much of these problems that are problems for you can be solved with the technology. All right. So, questions, and I'm going to jump into the data mesh. Data mesh. It's interesting when I do presentations, like I was at SQL Pass, and there was maybe over 100 people in the room, and I asked how many people know what data mesh, and I would say about 80% of the hands went up. How many people are building a data mesh? And I think there was one hand that went up, and I said, have you put this in production? And that person said no. And that's a common pattern I see. Everybody's aware of data mesh. Very few people are building it. Very few are in production. At Microsoft, there are a number of customers that are building it, generally very large customers. And some of them have been put in production. Some of them I probably wouldn't even call a data mesh. We'll get into that. But it's very much talked about. And I wrote the book in part to clarify what a data mesh is, along with the other architectures, and then to tell you what the trade-offs of data mesh is. At a very high level, when you think of the technologies architectures I've talked about before, the three of them, they're all taking operational data and they're copying it into a central data warehouse where the analytical data is created. A data mesh is very different. You break everything out into domains, and each of those domains, which could be HR and finance and supplier, they have all their operational data, but instead of copying that into a central data warehouse, it's kept there, and they create the analytical data. So just keep that in mind as I go through the data mesh principles. That's the big difference. And then you have to have a lot of good communication between all the domains, because somebody's going to come along and they're going to want analytical data from multiple domains. And so they have to have that interconnectivity. And that's where it gets tricky. Understand, though, that a data mesh is a concept. It's not a technology. It is a very big organizational culture shift. So if you read Jamek's book, he doesn't talk about technology in there. It's all about the data mesh. And a lot of it is theory, and a lot of it has not been implemented successfully to the full extent that she talks about in her book. And the technology that is used to build the data mesh. So we'll talk about a data mesh as a concept and what that means. Underlying the data mesh will be the technology that I already talked about, like a data lakehouse. So all these domains may all build their own data lakehouse, but you don't need to know about the technology when you're trying to understand the data mesh, and that's where I'm going with this. It's not something you can buy on eBay, and that's where there's been so much hype. It's very challenging to build, and this is no shortcut to it. So I will say, if you're going to build a data mesh, be prepared to spend much longer than you would in the other architectures. It could be worth it, but you need to be aware of the trade-offs, which we'll talk about. So data mesh at a very high level is made up of 4 principles. And I had to read Jamek's blog multiple times to finally think I get it and explain it in a way that's easy to understand, because her explanation is just very challenging to put into simple words. So let's do that, try to do that here. So the first one is domain ownership. The idea is the owners of the data should be the ones that are closest to the data. So if I have manufacturing, sales, supplier, if they copy the data into a centralized location, well, who owns it? Traditionally, it's been IT. So now you have this battle over who's owning the data and who should be the one cleaning it. With the data mesh, that argument goes away. The domains own it. So manufacturing is going to keep that data and own that data. And at least in theory, that makes it easier to do things like clean the data because they know it, the data best, so they should be the ones that clean it. That's principle one, domain ownership. Principle two, data as a product, means each of those domains has to make the data, the analytical data that they are now going to create, and then make it presentable or easier for others to get access to. So now each domain has got to go and build their own domain teams. They have like a mini IT team. They're going to have to create their own infrastructure where they have the compute and the storage. And they're going to have to go and write the code and the procedures to go and convert the operational data into analytical data. Then they have to make it easy for others to pull that data, because in a traditional data warehouse, everybody's pulling it from one source. Now they're going to be pulling it from multiple domains. So you have to have each of those domains creating some interface. Generally, they follow some contract that all domains follow that makes it easy for people to pull out the metadata to see what they have and to pull the data once they find something that they want and need. Well, you can imagine, gosh, I can have all these domains. Some customers have dozens and even hundreds of domains, and they're now all going to build their same solutions. Can we make it easier for them? That's the idea between principle number three, self-service data infrastructure as a platform. Is think of it as, could I give each domain a script that they can run that will fire up everything for them? Maybe ideally they just enter the name of their domain and it creates their storage and the compute and the ETL and all the security of that. We don't have anything anywhere near that, but maybe you can at the very least help automate things so each of those domains are not starting from scratch. They have some scripts they can follow to build things out. Maybe they use a product like Data Fabric that makes it easier for everybody to get started, and you create some framework, some templates and whatnot for them. Kind of along with that is number four, principle four, federated comprehensive governance. We can't have each domain go in there and defining their own rules and modeling data their own way and doing their own security. So you have to have, and this is where it gets so confusing, 3 and 4 are our centralized teams that are going to help those decentralized domains by giving them some code to build stuff, and then also by giving them global rules. An easy example is we need to have a rule that if you have addresses, you use 2 digits for the state instead of the full name. We can't have everybody doing it different ways because it's going to be really difficult if we try to combine all that data. There may be a lot of regulations they got to follow, so you have to give them what they have to follow. Even modeling the data, you want everybody to do it in a similar way, so it's not really hard to combine that data. And then definitely something like security, you can't have somebody using completely different types of security. That's going to be a nightmare to manage all that, and then to combine data with different security systems. So that's the 4 principles on that. And Douglas has the questions. Departments really don't want to take ownership. They prefer to let the IT team do it, and them to be decentralized over the data and also be the business experts. Yes, so that's one of the concerns I have. I have many concerns about data mesh. I listed in the book. Again, if you read them all and you're like, oh, this is not a big deal, great. You've now prepared yourself to be aware of some of those problems. This way, if you're running those problems, you're like, okay, I knew I was running this problem. I'm prepared for it. I read James's book. But you're going to have a lot of problems that are just going to be too much to overcome. One of them will be is domains going, I don't want to do all that work. If you want the data, take it. I can barely keep stuff running. So right away, that knocks out a lot of customers that I deal with. There's a lot of confusion on what these 4 principles are. And I try to clarify with them. And then I go, well, if you're going to, you may read these trade-offs with a data mesh, these concerns, and go, I'm not going to be able to data mesh, but you will still get some benefit out of learning all this, because as an example, domain ownership, you may like, oh, that's a good topic to have a discussion with. We're going to build a data lakehouse, but let's talk about who's going to own that data. So it can lead to many different great discussions, even if you're not using a data mesh. Then you get into what is a data mesh is, do I have to follow all these principles fully to call it data mesh? What happens if I follow the first 3 principles, but I don't do 4, or I do the first 2, but I don't do them fully? Can I even call it a data mesh? And that's where in the book I talk about a minimal data mesh, and I don't have a great answer, but that's where the confusion comes in. I have some customers that are using the first 2 principles barely, and they're calling it a data mesh. I'm like, man, that's really a data lakehouse with a bunch of workspaces. Then even worse, you have some virtualization companies come in there and say, just use virtualization over all your data lakes and data warehouses, and that's a data mesh. No, that doesn't follow any of the principles. So don't call that a data mesh, but that's where a lot of the confusion comes in. If we look at the architecture of a data mesh, the decentralized part are the first 2 principles. The 3 and 4 are going to be centralized teams that are going to do that. And that's where people get really confused. But those centralized teams could be made up of individuals from those domains, and usually is, but those are going to be a bunch of people getting together and coming up with those standards, because you can't have each domain coming up with those standards. It wouldn't make any sense. Then you get into debates about, like, well, if I'm going to do governance and I need to monitor it, is a central team monitoring it and applying those security and other things to it, or is the domains doing it? Usually the domains do it with maybe some slight centralized things that the team may do, the first principle number 4, and same with principle number 3 in there. So that's another area where each company is different on who does what. So the use case for data mesh becomes, well, we solved the ownership problem. We, at least in theory, satisfied the quality problem, because the people who know it best are going to clean it. That's where I go, well, that sounds logical, but in my experience in almost 40 years, sometimes the domain people don't know anything about the data, and ITs are more experts. And then you get into somebody from IT, which is a concern I was going to touch on, but somebody from IT needs to know all the data, regardless, because they're going to create models to put it all together, because you're going to have to keep it all together, pull it all together for some reporting in there. And if you don't have a person like that, then yeah, good luck and have an end user try to figure it all out. The other 2 things about, and these are the biggest things I think about data mesh, is the scaling. The idea is organizational scaling. As I have more domains, they each hire their own teams. I've solved or minimized the bottlenecks by having more people building the analytical solution, as opposed to the data gets copied to IT. IT becomes a big bottleneck, because there's only a handful of people there, and they're getting all these requests for data, and they're going to get log jammed on that. So that problem goes away. Without data mesh, the more data you have, the bigger the bottleneck becomes. With a data mesh, the more domains you have, the more people get hired. I know that's a concern, but that's the idea. You're scaling out. And the same with technology scaling. Really the same thing applies. Instead of having IT have to upscale all of their technology and handle all this big data, they don't need to worry about that anymore. The organizational, because each domain is having their own infrastructure, the more domains you have, the more infrastructure you have. I now have technical scaling. So that's the big thing about data mesh. Again, it sounds great in theory, many problems with that, but you get the idea, hopefully. Right, Douglas, you have a lot of good input. Banks do not want to hear about hiring people. One of the big concerns is you go to a domain and say, you have to hire people, and they're going to like, we don't know how to hire people. We've never done it before. You guys have done it. So, all right, now you have the risk of they're going to hire people that are not good at building solutions. They now have the budget to hire people. And this goes into, I don't want to get into it, but the days of Inman and Kimball and data marts, and a lot of what we see at data mesh is not new. It's just repackaged up in a nice way. And I give Jamek a lot of credit. It does sort of a lot of good conversation. It is a good solution for some people. But I remember having this 20 years ago and having these data marts and all these individual domains. We didn't call them domains, but same idea. We're building the solutions, and then people go like, well, that's not cost effective. We need to centralize everything and have a team do it instead of all these people doing it and having all the duplication of effort or duplication of infrastructure. And so anyways, that's a concern about the data mesh. What you'll wind up if you build out a data mesh, as an example of a healthcare, is you have a bunch of domains. Each of those domains have products. And this gets into, they call it DDD, data design domains, which could take months for customers to come up with. And this is the biggest challenge with a data mesh, is you have to reorganize your company. Now, it's easier for some financial institutions and in some cases banks, because they're already designed with like domains, so there may not a lot of be restructuring. Other companies forget about it. They have to do tons of shuffling of people and systems along. So that's where right away you get huge pushback. But in the end, if you do it, you'll have something like this: a handful of domains, could be dozens of domains, and in each of the domains you have a bunch of products, generally broken out by your systems that you built. That's how domains usually function. But then you have to look at the business capabilities and come up with that. And there's a lot of good books out there. One of my friends, Pete Hine, at Microsoft, he's at Microsoft too. He's built one that goes deep into this. And what you have when you look at the logical architecture is you could have source aligned domains, but you can also have consumer aligned domains. And Jamek goes through this for a book, because the source aligned domain may be too difficult for people outside of supplier, as an example, to understand. So you create another domain that maybe simplifies things or uses different terminology to make it easier for the consumer to understand. You also may want to combine domains for performance reasons, like profit and loss. Maybe it's going to take data from a bunch of them. So instead of trying to write a query that's going to go out and on the fly query all that data and create the report, instead you aggregate into a domain, kind of like we used to do with cubes. Well, this is what she talked about in her book. I have some problems with this, because to me this goes against the spirit of the data mesh. Now, if you're using consumer line domains, aggregate domains, you're centralizing the data, and who owns the data? So you're kind of violating the own principles, and then now you have scaling problems and whatnot. So that gets into concerns, a lot of concerns in there. This is just maybe 1/5 of what I have in there. And I've talked about a lot of these concerns on here, but just a couple others to point out is, imagine if you're in a company, you're going to go to the domain and you're going to say, now you have to build out this analytical data IT's not going to do anymore, and you're going to go and it's going to take you a year, maybe 2 years, and they're like, we don't want to wait from that. We need to get other stuff done with the analytical data that we're hoping you're doing. Now you're going to say we got to do it, and it's like, I'm not going to wait. Well, okay, now what happens if you have domains? It's one of the other points on here. If they don't want to be part of the data mesh, now you have these data silos out there. Now what are you going to do? Well, the answer may be you still have to centralize the data, so you have a combination of some data mesh and some centralization, which I'll show on a slide in a minute. And then the last one is probably a big one too, is who's going to see the big picture of combining all this data? Before it was IT. They would collect all this data, say we're going to have some models that we're going to build that are going to use a combination of data. If you have everybody doing their own thing, who's there to combine all this data and create those models? You still have to have that. And that's one of the things that Jamek says you don't. I disagree. And that's a big problem with people building data meshes who want to combine the data. So Elena says, I worked in a setup like that, and there's business units who had their own mini software team, and there were a lot of data issues. An executive team would complain about reporting from these different groups, giving different reasons for the same areas. There were lots of issues. Amen. And that's what you're going to have. You're going to have a lot of issues with each of those domains now doing their own thing. Great comment. Thanks for that. So this is interesting. Jamek in her book on page 272 says, should you adopt a data mesh? You need to score medium, higher on all these categories. And look at this, I would say 99% of the companies I deal with are not going to score medium to high on this. You look at tech at core, early adopters, especially in the government industry, forget it. But even in the commercial industry, there's not many early adopters. Be already domain oriented. Most are not. Long-term commitment, executive support. How are you going to convince all these people to completely change the way they're doing their reporting, to get them to buy into the idea of creating the analytical data instead of IT, and following these contracts to make their data available? And essentially you're pushing a lot of extra work, because now you've got to build your own infrastructure, you got to hire your own teams, and they're going to go, why should I do all that? And if your answer is for the greater good, yeah, good luck with that. So a lot of companies, unless they have this groundswell support and get people really excited about the mesh and see the benefits and get almost everyone bought in, they're not going to be successful in that. So this is, again, know whether you're a good candidate or not. And if you're like way off on all these, then yeah, just don't go down the data mesh route. So in the end, this is how I see the future of it is as I touched on just a second ago, there'll be some centralized solution, there'll be data mesh. So companies I see now are saying, well, we're going to start to build a data mesh. We're going to take new data and we're going to make that part of the mesh and keep that centralized data. Because in the end, even if you're going to build a data mesh, you're going to have to have a hybrid for a while. You can't just flip a switch and everybody's in the data mesh. There's going to be this transition. And so one way to do it is to start with a couple maybe data meshes that are new data and learn from those, and then start creating taking a centralized data and pulling some of that out and creating data meshes, and then go as far as you can go. Try to give everybody buy-in, but if somebody doesn't buy in, no problem, you still have the centralized solution. So you're not getting all these benefits of data mesh for all the data, but you are getting some benefits of the data mesh in there. Okay, and so leading to getting to the end here, when to use each architecture, I kind of summarize. I still see some companies using modern data warehouse. Usually if it's a very small amount of data, they're using relational data warehouses. Data fabric is still widely used. If you have to do a lot of extra, if you have a lot of extra data, then it's all different types of there. You're going to look at a data fabric. Again, it's just maybe a new fancy name for a modern data warehouse. But most customers are building data lakehouses, and I say use it till you can't, and then copy some of that data. So go down the path of building a lakehouse, see if you can get away with not using relational storage, especially if you're using a product like Fabric, and you run into a problem, then you can copy that data into some relational storage. But there's a lot of workarounds now and more to come with Fabric. So I'm hoping most of this will go away for all but a handful of use cases in there. And then data mesh, you have to be a really large company, domain oriented, already having major pain points in that. And that's where I argue with some people with data meshes. Well, all these big data solutions are failing, and it's not working, and centralized solutions can't handle big data. I call bull on that. I've been involved in this for a long time. I've seen plenty of customers build really great centralized solutions. The technology is advanced. Some of them are dealing with petabytes of data. They're making it work. So the reasons they're failing are not usually related to architecture. They're related to the people in the process, or they just completely chose the wrong architecture from the beginning. And I talk more about what makes this on my book. But in the end, most people are going to use a combination of all these. And there's no blueprints that I could just ask you a bunch of questions. I'm gonna go like, here's the architecture that you should create. Every customer is different. And I have a lot of architect design sessions. Again, I'm touting my book when I talk about how to do an architect design session in there, and then use a combination of these. All right, in the last couple of slides, data mesh from Azure is very short because data mesh is not about technology in there. So there is pieces of that are helpful for a data mesh. In Fabric, you have what's called domains, but domains are nothing more than assigning workplaces to a domain. So you still got to go all the work of how are we going to design this domain, and all that work is going to be done outside of technology. Then when you design it, then you can build workspaces for those domains, and maybe you have just one workspace, maybe you have multiple ones. So I put in there, how does this help with the 4 principles? It helps a little bit with domain ownership. It doesn't really help as data as a product. And even the others, it doesn't really help much. So it helps a little bit there, but it again, there's no data mesh in the box. you're going to do everything outside of it is that cultural and organizational shift, and that's going to be the major part of it. And then when you get all those domains, each of those may have their own fabric. Or you could have one fabric, so they could have their own fabric, in which case this slide doesn't apply, or you can create one Microsoft fabric that everybody's using, in which case you break it out of domains. And this goes into OneLake, and Microsoft is a giant data lake, and within that data lake you create these workspaces, and all those workspaces are assigned to the domains, but in the end all the data is centralized. And this is where you can still build a data mesh. Even Jamek says this is okay. Again, to me, it goes against the spirit of a data mesh, is that you can say, instead of all the domains having their own data lake, we're going to have one data lake, in this case, OneLake, and we have all the domains store their data in there, essentially in lakehouses, which are just folders within there. So that gives you a big benefit. All the data is in one location. It's easier to monitor and have security over it. And then performance is greatly increased because you're not having to copy all this data all over the place. They're all sitting in one spot, right? But again, now you're centralizing the data. Now you have the technology scaling challenges and that. And then you can even argue who owns the data now, because it's all centralized. But you can then say, well, we're just going to have each folder in OneLake is going to be given security that only the domains can access in there. So anyway, it's kind of a trade-off between one and the other, centralizing and decentralizing, and that's where it's a big trade-off in the storage component of that, and that's really it. So you have this OneLake that could unify all this data together much easier than having separate data lakes. All right, look at that. I'm almost exactly on time. This deck, which I'll make available, I have some resources on there. Any questions? If I'm happy to stay on a couple of more time, even though it's midnight here. I work late at night. I get a lot of work done there. So send me an email. And then the book I mentioned from Pete Hine is Data Management at Scale. That is if you want to get into building a data mesh and the data design domain. He does a great job of that. So I wanted to plug him there. So that's it.
While we wait for questions, James, thank you for a good presentation.
Yep, my pleasure. All right, so
you mind if I ask the question?
Oh yeah, great. Oh, we can have live people. Awesome. Go for it.
Yes, live humans. Quick question. One of the things we've come across, like trying to build a data lake, and a challenge that we're finding is loading the data and finding kind of a way to identify the delta to load, since you don't want to be loading everything all at once. And what are the tools, I guess, because like we tried click replicate. There are some issues with, like, for SQL Server using replication or CDC. All of them have their own issues. Like click replicate has problems. We found, like, if you change your default values, it doesn't pick it up. Some of the other issues with using replication, issues with using CDC. So what do you use? What have you seen? What do you recommend?
Are you telling me that these products don't do all the promise and they just don't gloriously work fine like they say they will? Again, I've been doing this for so long. I feel your pain. You get this tool, you think it's going to be great. It was touted to be great, and you run into some issues. Oh, they didn't tell you about this. And
the salespeople never tell you that the whole story.
Right. And I'm a salesperson, but I try to tell people, because I've been in those trenches on that side of things in there. So I try to be upfront with them. And there's some people are that way. Generally, the people have been through the pain. And there's no easy answer. So at a high level, when you're talking about copying data into a data lake, you have two ways of thinking. I can do a flush and fill. I can take all the data from a table and delete everything in the table and copy it into there. That's the flush and fill. Really easy to do, but you can't do that if you have a large amount of data. That's very, very small tables in there.
That's our problem. So we have a lot of data.
Right. So what you're getting at is incremental updates. Can I take just the data that's changed since the last time I run the ELT, and maybe that's every night, and there's many terabytes. So, okay, great. I have these many terabytes. Well, the first challenge is, can I tell the data that's been changed? And again, I actually have a section in the book that goes through this. But the idea is, it's easy if there's a timestamp on that data, but what happens if there's not? Uh-oh. Well, maybe I need to use technology like CDC or replicate like you're talking about. If I have timestamps, I'm not going to go that route. I'm just going to go and use something like Data Factory, find out what's been changed, pull that data over, and then use something like a merge command or something more performant to get the data merged in with what's in a destination on that. So it really comes down to, can you see that the changes? Now, also added to that complexity is, what is your pipeline from that source system to the destination on that? Something, if you're on-prem, you don't have to worry about, all the servers are really close. Well, now we have servers that may be on-prem with that data going up to the cloud, and it's just like your internet connection. If it's not a good internet connection, you got to move multiple terabytes. Well, that could take forever, and I can't do it at night. Okay, well, one solution is you break it up and you do things during the day, so you're not having one big giant thing to upload at night, or you get a bigger pipeline like Microsoft has Express Route, so you can pull up that more data. So you got to think of creative ways then, which adds more complexity to it. Now you could go down the route of something like replicate, which replicates the data as it gets changed in the source system, and you land it in the data lake, and that could be the solution. But if you're running into there's issues, it can't work with certain keys and whatnot in there. So some customers will use something like replicate. Now,
Replicate, you mean click replicate? Is that?
Yeah.
Okay.
Replicate.
Yeah, because at night is a relative concept if you're a global organization.
Right.
There is no night. Yeah.
Yeah. So, right. So this is where every use case is different. And now you may have 10 different source systems or more, and they all do things differently. So how are you going to get that? So that's the long answer. But the really long answer would be, I'd have to sit down with you and just whiteboard it and go through your situation and then come up with some ideas that maybe you haven't thought of that would make it easier. But there's no easy solution to this.
Okay.
It's very challenging. And I've dealt with customers, they got 100 sources, and it takes a very long time to pull all that data and collect it. I mean, I'm actually going through a kind of a side note, a customer that's not a customer, a company that's being sued because they were trying to build a data lakehouse and it was taking so long, and they're running all these problems, and they kind of hired me as a subject matter expert to go and see what happened, what went wrong, because it took so long. And it's just, there are fundamental issues that people are not aware of going into that makes that a challenge, and you have to be aware of that, and you have to know the right technology to use. And it all comes down to getting pretty smart people that could figure all this stuff out.
All right, thanks.
Feel free to send me an email, and we can hop on a call and I can talk more about it.
Sure. What's the name of your book again?
Oh, you seem like you're somebody I said in the audience to pump my book up. That's it right there.
Okay, I'll grab a screenshot.
Yeah. So, and I'll tell you this, and I'll tell for people on the call, if you're still here, if you want a copy of the book, just send me an email, and I'll give you the free copy. It's not been completely grammar checked yet, but it's 90% of what the final book's going to look like. So I'll just give you that copy, and then you'll have that to go and learn from.
That's cool. Thanks.
Yeah.
Thank you.
That's what you get for staying up late with me and listening to my presentation. So just send me an email, and happy to give you one. Anybody else?
Yolanda, would you like to wrap up?
What are we doing? Are we doing the t-shirt? We're not doing the raffle anymore, right?
Right. We can contact both James and Sam after the meeting for t-shirts.
Okay.
And when the book comes out, I can give away free books, but I'm doing that anyways. Awesome.
Okay. Let me go back to my slide deck. And I guess we can wrap it up. Thank you for your awesome presentation. Thank you everyone for joining our online meeting today. With that, thank you. Have a great day and see you next time.
Thanks,
Thank you.
James. Thanks, everyone. Bye.
Bye.